So we're going to start off today by looking at writing an interval notation. This is just one way that we can represent a solution. And we're going to build off of what you did in lesson 1.5, where you were working with inequality symbols. So just like we had those open circles that showed that the value was not included, we use parentheses that also means that the end values are not included. However, if we use these brackets, then that does mean that the values are included, just like you had a closed circle when you graphed to show that the value was included. The brackets do not have to match, so on the left-hand side you might have a value that's not included, and on the right-hand side you may have a value that is included, or vice versa. You may have on the left-hand side a value that is included, and on the right-hand side a value that's not included. So again, the brackets don't have to match. The U symbol that you will see represents union, and we use this in the OR problems in place of the word OR. And as I said, you're going to see this in the examples that we do together shortly. The infinity symbols are like figure eights on their sides, and positive infinity can be represented with a plus and then the infinity symbol, or just the infinity symbol. Both of those represent positive infinity. Whereas if you have a negative in front of it, then that is always negative infinity. Infinite solutions is represented as negative infinity, comma, positive infinity. And you'll notice that they have parentheses. Infinity should never have a bracket next to it. So anytime you use an infinity symbol, you should always have a parentheses next to it. And it just means all real numbers. The reason that we don't have a brackets not included is because we don't know the beginning value of infinity. We don't know the ending value of infinity. So we use parentheses instead of brackets. But it really just means all real numbers. And then finally, we have an empty set, meaning no solution. We have two brackets with nothing in between them, or we have that zero with a slash through it. Both of those mean no solution or an empty set. So let's look at a couple of examples. You have more problems on your paper, but we're just going to start by looking at number 1 and 2 under the first section. And your directions are to write each inequality using interval notation. Well, we can read number 1 as n is greater than negative 8. And to write that, we're going to start with a parentheses because it's just greater than, it's not equal to, negative 8. And it goes all the way to infinity because it's any value that's greater than negative 8. So we represent that with parentheses, negative 8, comma, infinity, and then another parentheses. Example number 2, we have b is less than or equal to negative 9, or b is greater than 1. So we will represent that, you have that word or in there, which shows you should have that union symbol. We're going to start by the b is less than or equal to negative 9. That means any value that is less than or equal to negative 9 is a solution to this. So from negative infinity, remember always use a parentheses, to negative 9, and we use the bracket because it's allowed to be equal to negative 9. Then in place of the word or, we put the union symbol. And then we have b is greater than 1. The 1 is not included, so we start with that and we use a parentheses. And it goes all the way to infinity because b just has to be greater than 1. So again, you close that with a parentheses. So you have some more examples that you're going to try on your own, and you can check your answers online later this evening. The next section is writing each graph in interval notation. So this time we're taking the graphs and we are writing them in interval notation. So starting with number 1, we have negative 3 and it's not included, and it goes all the way to 5. So in that 5 is included. So anything between negative 3 not included all the way to 5 included is a solution. So we write that as negative 3 with a parentheses on the left hand side to 5 with a bracket. And notice as I'm reading these, that comma I'm reading as a 2. So I say negative 3 to 5. And skipping to number 3, you'll see that that arrow going all the way to the left is going to say that we're going to start at negative infinity. So we don't know where that graph is starting. And then we go to 3 or -3, and it is not included. There's an open circle there. We don't have anything in between those two, and then we start at 0, not included, and we go all the way to infinity. So when we write this, write it as parentheses, -infinity, comma, -3, parentheses, union, parentheses, 0, comma, infinity, parentheses. And again, you have some additional problems to practice with, and I would encourage you to practice those in class and try to check some of your answers. If you don't finish, you can always check them at home. And please know that it's going to take a little bit of time for you to get used to this notation if you've never used it before, which most of you probably have not. But once you get the hang of it, it will become easier. So now we have 2 more sections. Put an interval notation and draw a graph of each inequality. So the first example there, we have x is greater than or equal to 4. So again, it says it has to be greater than 4, which means it's going to the least value is 4, and it is included, so it's going to be a bracket with a 4, and then it has to be greater than it, so it's going to go all the way to infinity. So bracket 4, comma, infinity, parentheses. And then graphing that. So you should be able to graph the inequality, but you're eventually going to just be given the interval notation and have to graph it, so we're trying to match that up. And so we start at 4 included, so closed circle, and we move or any value to the right, any value that's greater than 4. Then moving on to number 6, we are to write each interval as an inequality and draw a graph for each. So now we're taking the interval notation and turning it into an inequality. So we have parentheses, -infinity, comma, -8 included, which means that the x value has to be less than or equal to -8. And if we graph that, we have -8 included, and where arrow is going to the left because it's -infinity. All right, so moving on to set builder notation. This is another notation, and the solution of an inequality can be expressed using set builder notation. And essentially it's the same thing you would write as a solution, just a little more formal. And yes, that word right is spelled incorrectly. Example, the first example is to solve 2y plus 6 is less than 10. So you're literally going to solve that equation first to solve for y, and you get y is less than 2. And that's typically at this point how you would leave your answer, or you might graph it. And now you know how to write that in interval notation, but another form is set builder notation. And it looks more formal. The set builder notation for this answer is squiggly bracket y, there's a bar, vertical bar, another y, and less than 2 with a squiggly bracket at the end. And you're just adding the variable you are using at the beginning and then separating your answer with a vertical bar. And the way we read these are the set of values for y such that y is less than 2. So that vertical bar we read as such that. So y such that y is less than 2. And again, this is going to be something you're going to have to practice. Practice writing, practice reading, practice saying, so that you become more familiar with it. So looking at example number 1, we are asked to write each set of numbers in set builder notation. So this example says 5 is less than x. So you might want to rewrite that in a way that you're more used to reading, whereas x is greater than 5 is really what that says. If I say 5 is less than x, it's the same thing as x is greater than 5. Then from there, I'm just going to put it into set builder notation, which is going to look like this. X such that x is greater than 5. And literally, that is all you write. So you might find set builder notation a little bit weirder, however, you might find it easier to use.